Okay, welcome everybody. So my name is Dave, and this is going to be hopefully up to about an hour. I'll leave a little bit of time at the end for questions about microservices and security. It's a modified version of a talk that I gave at Spring 1, so if you had a chance to see that, then you can catch up on the bits you missed, and if you didn't, then it'll all be new. So we will very briefly discuss microservices. I know that a lot of people are very interested in them at the minute, so I don't really need to explain what I mean by that very much. But I will talk more about what you would need to do to secure a microservice and to make a system composed of microservices as secure as possible. Especially, I'm going to concentrate on how you would use Spring to do that. And I'll show you some really easy ways to get something working really quickly. And the punchline for that is I'm going to be using Spring Security OAuth and the new Spring Cloud Security project, which we just set up. Okay, so microservices, everybody's heard about them, right? And so there is demonstrably, I think, quite a strong trend recently towards distributed systems, number one, and with what I would call a cloud-first or a modern lightweight architecture. And people tend to call those systems microservices. They're really systems composed of microservices, and the microservices then start chatting to each other. And we want to see what people would do to make that chatter secure, so to make sure that microservices know who each other are and can authenticate appropriately. So it's the usual security questions, right? So the requirements are basically, stop the bad guys from accessing your resources. So you've got two axes of that. In Spring Security, we tend to refer to them as authentication, which is identity, and authorization, which some people would call permissions. So the questions we have to answer basically come down to this. How is that information conveyed to the service that you want to interact with? And on the service, how is it going to be decoded and interpreted? So I might be sending a token, for instance, in an HTTP request header. What's the service going to do to interact with that data? Also, in maybe some sort of back end or some business logic somewhere, there's going to be some access decision, and so we need some data to make the access decision. So permission is a loose concept. It might be the data I need might be composed of information that's in user accounts, roles attached to them, ACLs attached to the objects I'm interacting with, a number of other different things. So we need to keep an open mind and try and be as flexible as possible. How is that data managed? This is especially important when you have largish distributed systems. So more than two or three components. Basically, as soon as it gets bigger than that, then you start to have a headache about how to centrally manage all of the data. And how to protect the data as well. So, and then there's a final point here, which is often overlooked, and I'm not going to show you demos of this, but I'm going to mention it as we go through. How would you, if you're interacting with a RESTful web service, then it's a reasonable question to ask, how can the service verify that the request hasn't been tampered with? So that's a relevant question to ask. We'll see if we can do anything about it. Okay, so the first thing you might try would be the simplest possible answer would probably be for an HTTP REST service, it would be basic authentication. So probably everybody here knows what that is. But you could think of it as sort of something of a lowest common denominator. It's really easy to set up. It's supported everywhere. Lots of clients, lots of languages, good support in Spring Security, of course, and Spring Boot and Spring Cloud do this kind of thing sort of magically for you out of the box. The example here is a curl command line client, which just shows you how easy it is, basically. So if I know the host name and resource path for the service I want to reach, and I know what protocol it's going to be on. It should be HTTPS. Then with curl, I can just put the username and password embedded in the URL like this. And that's kind of a convention that curl uses and other clients do as well, to say, these are the username password I want to present. When it's done in the HTTP protocol, it will actually be translated into a request header. I'll show you that actually in a minute. So how would you do that? With Spring Security, very simple. What I'm showing you here is a Spring Boot CLI app, but it isn't actually all that much more complicated if you wanted to do it in a full-blown Java application. But to demonstrate that this works, let me just copy it and paste it into a plain text file. Basic.groovy, should we call it? So there we are. There's a plain text file with a grab on the top that says, get me Spring Security as a dependency. And then it's a REST controller. This is Spring MVC with a home page that tells me the status is OK. So to run that, I do just make sure GVM use Spring Boot. I've got a Cloud M2 version of Spring Boot running here. So I should be able to do Spring run twiddle/tmt, that text file that I just set up. I don't need Spring Cloud for this, by the way. I just need Spring Boot, but I'm going to be doing Spring Cloud demos later, so I'll just leave it in there. There's the web app starting up. Takes a little bit of time. And then I'm going to drop back to another shell session here. I'm just going to try and curl that on localhost 8080. And so we see what happens. -B. All right, so I'm going to get back 401 unauthorized because I haven't tried to authenticate. And it tells me in the response that I need to authenticate with basic HTTP in the realm called Spring. And I can configure the name of that with a properties file. So how do I do that? Well, I need to know the username and password, don't I? So I'm going to have to send that request again. User, what's the password? I don't know the password because it was the default Spring Boot security, which is a random password. So I have to sign it in the log files. Hopefully everybody can see that. And I paste that into there like that. I'm curling my server again, and then I get my status message. Status OK. So the point I'm trying to make with that is really how simple it is. It's very simple. Everybody can understand it. Everybody can implement it. So what's wrong with it? Well, nothing actually. But you might ask yourself, like I had to do, where do I get the credentials from? It's fine if there's only one or two systems involved in this, or one or two components involved in this system, because you can sort of hard code the usernames and passwords, and maybe even do what I did and copy paste from a terminal. But it's going to get difficult if you have to have a bigger system where you can't share the secrets very securely. So once you get a bigger system, it's going to be more difficult. Another disadvantage of this is it only supports username password authentication, and that's good enough for a lot of purposes, quick and dirty, and it'll get you where you're going, but you might want to beef that up at some point. The protocol itself only covers authentication, so I can only say who I am. I can assert who I am, but I can't assert any kind of permissions. I have to add that in as a separate feature. Now, Spring Security does support that, but it's not actually covered by the protocol itself. And the final thing I'm putting here is going to become significant when we start looking later on at OAuth2. So in this microservice world where you have sort of users interacting with the whole system through some edges of the distributed system, there are machines that the system is composed of, and there are users which are interacting with it. And it's often, in that case, useful to be able to distinguish when you're serving a request as a service and you want to ask the question, is the entity who's asking for this information, is it actually a user or is it just a machine? And or is it maybe a machine acting on behalf of a user? And that's the key distinction that we'd like to make, and which is quite difficult if all you have is a username and a password. So another option we might consider, if we were thinking along these lines, is a different kind of approach to authentication, basically. So certificate-based security. I think this is an interesting option for microservices because, SSL is ubiquitous, and, it's a gold-plated standard, basically, modulo bugs in OpenSSL and things like that. But it's been around for a long time. It's relatively easy to get right once you know what you're doing, and it's pretty secure. So Spring Security also has good support for it. So it's called X509 certificate authentication in the sort of crypto security community, and that's what Spring Security calls it. So the basic idea is that you have an SSL termination in your microservice, and instead of just requiring the protocol to be encrypted, you also, it's just a switch that you can throw on the server, basically. You say, in addition to doing a handshake, an SSL handshake, I also require a certificate to be presented at the time that the handshake is initiated. So the client has to not just use, so this is the client here example. I've got a curl client, and I'm going to hit HTTPS, so that's the protocol. It's not just hitting the endpoint with the protocol, which would tell curl that I needed to do an SSL negotiation. It's also sending a certificate, right, in the request. And so I can set the server up to refuse any request that doesn't have a valid certificate attached to it. And by valid, it's the X509 rules, basically. It has to be a trusted certificate for the key store, which is available on the server. So it's sort of interesting because, if you have a key store anyway, if you're terminating your HTTPS, your SSL termination is actually already there, you have a key store, so you might as well load it up with certificates. There's an example of this. I've got a link here in my Spring 1 demo. I'm not going to try and do the demo today. I don't think I've got time because I've got a lot of other things I want to get through, but it's an interesting option. Also, nothing wrong with it. There is, however, usually there's no user identity, at least in the way that I presented it there. It's sort of the machine that's identifying itself with this certificate. And sometimes you can associate a machine with a user if you sort of install it in everybody's browser. So browsers, if everybody has their own identity in their browser, then yes, you have user identity. But you certainly don't have a distinction between users and machines. I guess another drawback that I'm listing here is you do need to set up all those key stores and certificates, and you need to do that properly. So it's a little bit non-trivial, but there are some organizations where you'll need that anyway because you'll have certificate-based browser authentication just set up everywhere. So distributing certificates and key stores is a known and solved problem, and in that case, you might consider this to be a useful option. Certainly, it'll protect you from accidentally opening up your services to random browsers. Okay, so the next option might be, it's quite common actually to see these custom authentication tokens. So roughly speaking, we're talking about a header-based authentication if you're doing it right over HTTPS. So the client sends a random identifier in the header of each request, and the identifier has some data encoded in it, which was created from some central service. Okay, so there's a central service which creates the tokens, associates them with some user authentication or machine authentication, depending on what you want to use it for. Store that maybe in a database, maybe encode the credentials in the token itself. A common thing to do with this is to to provide a UI for developers on your systems. It says, okay, here's your token if you want to interact with our service. Copy paste this token and use it in all your requests. And then the services that want to consume that have to decode the token every time they want to service a request. Spring Security has some sort of basic machinery for this. There's some base class support, basically, so you can wire up your own authentication processing filter using this abstract base class that I'm quoting here. Another option that I'd like you to consider if you've got time is definitely worth having a look at Spring Session, which is Rob Winch's latest plaything and awesome new project. So the idea is that you basically use Redis or some commonly available, there's a Redis implementation out of the box, which is why I mention it. Some commonly available key value store, you use that to do your servlet session storage, and he makes it completely trivially easy. You just set up a servlet filter in your app and everything just works. And the reason that's interesting is because the session identifier, so the J session ID, if you're used to the HTTP servlet terminology, the J session ID is now pretty much described. It has all the features I just described for a custom authentication token. It's a random identifier and it's stored in a central database. So you can use it to do authentication. There's an interesting example of that. I've got a link at the bottom of the screen here, also from my Spring 1 demonstration. So I won't show that, but I'll describe it briefly. It's a pair of apps. One is a front end with JavaScript, and the JavaScript has to contact a back-end service which is protected using an authentication token. And the authentication token is the same thing as the login, the session ID for the front end. So they're basically sharing a J session ID, although one of them is using them in a different way than the other. One of them is just using it as a traditional HTTP session identifier, and the back end is using it as a sort of custom authentication token. So it's an interesting approach, and it does that. It's really simple to set up. Another example from real life is GitHub. So they have a GitHub account, and you can grab a token and then interact with their API. And interestingly, you can also use that token as a password in HTTP Basic, and I think that's quite a clever thing to do because it means that the password is temporary. They can cancel it anytime they want, but because it's HTTP Basic, it's really simple to operate and to be a client of. Okay, so what's wrong with that custom authentication token? Well, again, nothing. It's if you do it right, HTTPS, opaque tokens, there's not much that can go wrong. But okay, for one thing, you can't separate the machine from the user again, at least not out of the box. You could take steps to do that, but you would be sort of starting to redefine another protocol if you did that. It's fairly coarse-grained, so you can see that with GitHub. Basically, you get one token and you use it to activate all the resources. It doesn't actually distinguish between different levels of access. So that's fine for developers, right? That's why GitHub does it that way, but it might not be great for a more complex system where users are not all developers. It's also not a, quote, standard, but you can pick up some ready-made implementations off the shelf in various places. Grails, I think, has a plugin that does something like this. And the final drawback, which I probably could apply to everything else we've looked at as well, except for perhaps certificate-based authentication. To authenticate a user, if I'm a web app and I want to authenticate a user, I do actually still need to get their credentials in some form. I need to to generate the token, right? There has to be a sort of bootstrap process where the user proves who he is in some other way, and that tends to be done by collecting user credentials. You could design your way out of that problem as well, but what you'd probably end up with was something that was so close to OAuth2 that you might as well start with OAuth2. So if you want to fix the sort of, slightly awkward features of the quote, normal custom authentication token, then you probably end up doing something that's close enough to OAuth2. You might as well just do OAuth2. That's my thesis, at least, anyway. So OAuth2 is a standard, so that's a good thing. IETF for the group that publishes the standard, and has a committee of people who thought long and hard about it. It's pretty simple for clients and developers. It's not as simple as HTTP basic, but I can show you in a quick demo very soon how simple you can make it. So you have an authentication token. It's called an access token, and access tokens are designed to be able to carry information beyond just the identity. So you've opened up the possibility of having multiple levels of authorization. Different users can have different, interacting with different resources can have different levels of permission. There is a clear separation between users and machines. That's designed in the flows that the standard defines. And there is a very strong emphasis on not having to collect user credentials in an untrusted place. And that's, something that was given quite a lot of thought, so it's worth paying attention to. The basic idea is that machines can act on their own, which is called client credentials, or they can act on behalf of users, and I'll call that user tokens, but there are 3 different kinds of user token in the spec. So the key thing here is that if you're a resource that is protected by this kind of token, you can you have a contract with the authorization server that minted the token, and you can interpret the token content pretty much in any way you want. That isn't covered by the spec. Some of the contents of the token are, and I'll show you what will be wrong with that in a minute. What that will be about in a minute. Okay, so what would be wrong with OAuth2 for microservice security? Well, it's a little bit more complicated than some of the other things I've shown you. So yes, that's definitely a problem. You might find it a little bit harder to get off the ground than anything else. And the only hole that I can think of apart from that is that the last bullet point in my feature request for security isn't really covered yet by a standard, at least. There's no standard yet for request signing. So you can set up, hashes of requests and make sure that requests are not tampered with, but it's not part of the standard. Okay, so what does it look like? This is the curl command line client example, like the one that we did with HTTP basic. So it's curl. I'm going to set a header. That's what -h means. And I'm going to say in the header, I'm going to say what the authorization is. My authorization, instead of being basic, is bearer. So bearer means I bear this. In other words, I carry it to you. I'm carrying a token, and I'm inserting an environment variable there on that command line. And then that's the end of the header, and then I go to the resource URL. Very simple, once you've got this token. Okay, so the complicated bit is going to be getting hold of the token. This thing, in the terminology of OAuth2, is called a resource server. It's a resource in a server, so the thing that hosts it is a resource server. Now, the token is a bearer token, and it was created or minted by an authorization server. And the reason it's called authorization is kind of obscure, but it's to do with the fact that you're supposed to ask users to authorize the granting of the token. Okay, so if I wanted to implement one of those resources, so what could I do? So this is the simplest possible implementation that's a mixture of Groovy and Java, actually, isn't it? I could fix that. Take the public keyword out, take the return out, the return keyword out, and it's Groovy. It is actually valid Java, and it's using a feature from Spring Security OAuth2. So at enable resource server basically sets up all the machinery you need to do that in terms of filters and token decoding and sending responses to unauthenticated requests and things like that. It's all set up for you behind the scenes, and all you actually need to do, you can do more than this. Obviously, you can customize different bits of it, but all you really need to do is provide an implementation of this interface, token store. And token stores, you can guess, are responsible for, in this case, decoding tokens, access tokens. So you give it an access token, and it gives you back some information about the thing that's authenticated, whether it's a user, a machine, or a combination of a user and a machine. So that's really simple. I've got one running, actually. Why don't I just show you that? So what would be the best way to do that? So there's one running. Yeah, I've got one running on Cloud Foundry. I'm just going to hit that, right? So I'm going to curl -h authorization. So I think I'm going to find that my token's expired, so bear with me. Actually, what I'll do is I'll just curl it first, and then you'll see resource.cfapps.io. So this is an app that I deployed earlier with that basic implementation that I just gave you there. Okay, so the response is a 401, as expected, and the authenticate header in this case, instead of saying basic, says bearer. Okay, so it's not waiting for a basic authentication; it's waiting for a bearer token. I'm going to guess that my Cloud Foundry token has now expired. So if it has, then I'm not going to finish this demo. I'm just going to get another 401, but let's try it anyway. I had this token environment variable set up earlier. So yeah, it's still unauthorized. It doesn't tell me why it's unauthorized. That's standard security best practice, but the reason is because the token is expired. I'll finish that demo later if I get time. Okay, so that's a really simple resource server. Really easy to do. There are plenty of configuration options, like I said. If you want to protect different paths instead of just the whole application, you can do that. Using familiar idioms to explain security users is the aim of that exercise. Okay, so the counterpart of that then is the thing that generates the token. If it was a Cloud Foundry app, which is what I was trying to demo just now, that would be the user, the UAA, the user account and authorization server, which is quite a lot of code, actually, because it does a lot of special purpose things for Cloud Foundry. But a very simple implementation of an authorization server would be as short as this. Basically, it just says enable authorization server, and this is a client which I'm going to register. So a client is a machine, an app that wants to interact with resources and wants to have tokens granted for itself. So you can, there's a ... here because there's a number of properties you have to set on a client, but basically this is it. It's a few lines of code to get an authorization server working. Yeah, I can actually show you one of those, but I'm halfway through and it's half the time, so I think I'm going to move on to the next step. I can show you it running. Actually, yeah, why don't I do that? It's not that difficult to do. So here's this is a Java project in Eclipse. I've got a Spring Boot app, which is @enable auto configuration. You can see that, yeah. And here's my, as I said, @enable authorization server. This one's a little bit longer than the other one, but it does have the client registration. So I've got a single client here called ACME with a secret. And I want to be able to do password grant, token grants. And so to do that, I need to have an authentication manager. So that's what the extra bit of configuration here is about. I need to have an authentication manager to set on the authorization endpoints. So let me just run this thing. It's going to be running on port 8080, so is my other app still running? which is what that one says. Right. So that's one thing. Yeah, okay, didn't take long, did it? Okay, so, sorry, did somebody want to say something?
No, I was saying, yeah, you're running. You're back up and running.
8080. So I've got a UAA context path for this because I was testing a sort of simulated Cloud Foundry server. So there's a token endpoint, and to authenticate with the token endpoint, I need to be a client. So you saw that being set up in my source code just now. So that should authenticate me. And then I need to say what the grant type is. I want to get a token, but I want it to be a password grant. So to do a password grant, I need a username, and I need a password. And I'm going to have to cheat because I can't remember what the password is. Password. Okay, that's easy. I've got one user in this system, and hopefully this will get him a token. There you go. There's an access token. Okay. It's a UUID. You can tell that's the default implementation from Spring Security. And then I can use that access token to access protected resources, of which I don't have any running at the minute. So that was just to show you a token grant, basically. All right, that was really simple. So in that token are somehow represented. In that case, it was just a random identifier. So these things are stored in a back-end database, in memory, actually, in the out-of-the-box case. Associated with that token, I have to have a client ID. That was my ACME client. I have to have a resource ID, which is the audience of the token. Actually, that's optional, but it's recommended. I often have an issuer, so that would be the authorization server, maybe the URI of that. This is not specified by the spec. This is just good practice. You put the issuer in the token so that when the resource server is checking it, he can assert that it comes from a trusted authorization server. You'd be fairly well advised if there's a user involved to put the user ID in there so that the resource server can reason about that, and possibly also then some form of permission information. And the spec doesn't say how you should do this. The spec just says it's a token, and these are the rules you have to follow when you create one. And when you're decoding it, actually, probably the only thing they're really fussy about is you should check the resource ID. That's the only thing that they're fussy about in all cases. But obviously, more information is better because you can make more fine-grained information, more fine-grained decisions. Okay, so here's an example of a different kind of token. The Cloud Foundry tokens that you get from the UAA are actually JWTs. They're JSON web tokens. They are signed so that you can't manipulate once they're created. The contents are fixed. And inside that JSON, you will find the client ID, an expiry, an estimate actually for the length of time till this token expires. You'll find a bunch of scopes. So scope is an OAuth2 concept that we haven't seen yet. The scopes are a bit like sort of roles, user roles, maybe, but they're really just opaque strings. As far as the spec is concerned, they are strings that are exchanged between the parties in this protocol. So the authorization server creates a token with these scopes in it. The client can ask for scopes if they want to. I didn't in that demo that I just did, but I could have asked for specific scopes. And the resource server basically collaborates with the authorization server to define the meaning. In the UAA and in Cloud Foundry, you have period-separated scopes. And other people use different schemes. Some people use URIs. Some people use things that look a bit more like sort of user permissions. I think Facebook's in that category. So I've got scopes. I've got an audience for this token. So this token can be consumed by an OpenID resource. a cloud controller resource, and a password reset resource. I say who's the issuer. That's, in this case, it's PWS, Google Web Services. There's a username. That's an email address. There's a user ID, which is more of a unique identifier. There's also an email in this one because Cloud Foundry is a bit schizophrenic about whether it wants to have usernames or emails. They happen to be the same. And it's got an identifier for the JWT. That's a part of the JWT standard. So a JTI is a unique identifier. It'll only be ever be issued once for this token, which is the way you can track its contents, or lock down its contents, verify its contents. Okay, so how is all this relevant to what we came to talk about today, which is microservices? So these resource servers that we've been talking about, the ones that are accepting token headers, might themselves be microservices. So a typical picture would be you have a web app client maybe at the front end of your system, which uses authorization codes, grants, which is an OAuth2 protocol, to acquire an access token on behalf of the user. So you'll see that flow in a minute if I get time to demo it. You might have single-page apps that are JavaScript clients, so in the browser, which can and should, in my opinion, use the authorization code grants. But there is another thing in the spec called implicit grants, which is specifically designed for browser script clients. And an implicit client is, by definition, untrusted, which is why it's a good idea to maybe try and avoid it if you can. Authorization code grants give you more flexibility and slightly better security. Mobile and non-browser clients generally tend to use password grants. So in that case, there's no reason not to trust the user. There's not really any way you can get around it. You have to collect their credentials, and maybe you can modify the password grant. So the vanilla protocol from the spec is just what I showed you, username, password. It doesn't say you can or should do anything else, but we all know that there are other ways to do authentication, and so maybe you could have a multi-factor authentication credential included as part of the password grant. There's no reason why you couldn't. In principle, in practice, it's not in the spec, but it's quite easy to extend. So, and then the other thing you have is machine clients, so I would call other services, service clients, so intra-system calls. You can use client credentials, or you can use a pattern that I'm going to describe in a bit more detail later, so don't worry if this doesn't mean anything, because I made up that word, and I'm going to explain it later. So you can relay the user token from the front end to the back end. Whether or not that's a good idea, we can talk about it a bit later as well. So, so that's a sort of really basic rundown of Spring OAuth2 features, showcased a couple of them. A new thing we've done recently is Spring Cloud, and there's a Spring Cloud security module in that, which is a little bit higher up the stack again, a little further level of abstraction to make some of the microservice use cases really easy. It uses a lot of convention over configuration, so declare everything in properties files or environment variables is quite an easy and nice experience for deploying microservices. And the user experience for deploying these things on a path like Cloud Foundry is very smooth. That's the general idea. So we didn't look at the client side yet, actually. I could have shown you the non-cloud version of this. It's a little bit longer, suffice to say. So this is about as short as it can get, right? So you have a Spring MVC controller, which is decorated with @enable OAuth2 SSO. And that's all I need to run a single sign-on client against an OAuth2 server. And so in Cloud Foundry, what I would do is, in the example I'm giving here, it's a Groovy CLI app, so I can jar it up into app.jar, and then I can push it to Cloud Foundry. That's it. I have an example of one of those. I think that's the best one to show you. Yeah, the best one to show you is probably this one. So, I'll show you where this code lives at the end, so you can look at it yourself if you want. But in my demo directory here, I've got a load of Groovy scripts, and one of them is called SPA, Single Page Application. So there you go, @enable OAuth2 SSO. It's a REST controller in this case, and it has a single resource. Just standard Spring MVC, that bit. So the cool stuff is all here, @enable OAuth2 SSO. What's that going to do is going to throw up a security filter in front of all of this, and when any request comes into this application, it's going to do normal Spring Security session authentication. And if there's no session yet, what's it going to do? Well, it's going to do single sign-on with an OAuth2 authentication identity service. And so the prototypical case for that is Cloud Foundry. Let's see if I've got my Cloud Foundry stuff here. I'm going to create some cookies in case they're there already. They aren't. Okay. So my app is actually running on spardemo.cfapps.io. So if I log in there, the first thing it does is it redirects me to the login service, login run.pivotal.io, right? So I can log in there as, let's say, actually I'm going to choose a different one because it will be a slightly different user experience. Hotmail, I can remember my password for that account. So this is a Cloud Foundry identity account. So I log in as him. Then the first thing it shows me is still in Cloud Foundry here, like it's still in the login server. It asks me to authorize. So I have to authorize ACME on this URL to access my profile data. You've all seen something like this probably if you've interacted with Facebook, GitHub, Google, those kinds of OAuth2 process. So if I say authorize, it will let me in, and it will show me my greeting. Okay, so that greeting, this is actually an index static HTML page, which is just rendering the ID and the content. So there's a UUID, that one, and there's a bit of content. So that was a really basic SSO example, sort of self-contained single-page app. I go back to the slides. So that's it, basically. It's as simple as that. How did it work? Well, I've been using configuration conventions. So that app was bound to a service in Cloud Foundry, which actually wasn't called UAA, but it doesn't matter because that's just a string. So I bound the app to a service, and the service provided credentials, and the credentials were the equivalent of this YAML, basically. So it's a JSON object, but it has where to find the token endpoint, where to find the authorization endpoint, which is how you get that login authorization flow. It's got the client ID and the client secret, which I'm providing as an environment variable. It's got the this is a UAA feature in Cloud Foundry. There's a check token endpoint that allows you to decode a token. It's also a Spring security feature. You can do that, or you can use, in GitHub, they've got a user info page, so you can use that to get the same kind of information, basically decode a token. And that's it, pretty much. So those are the things you need, a bunch of URLs and some credentials, and you do it by convention. So that was the client side. On the resource server side with Spring Cloud, there's a slightly different pattern. So you remember I had to set up that token store. And so I basically applied the same convention over configuration rules to the token store and saying, if you @enable OAuth2 resource, then you want to do something quite specific with binding to the service or providing credentials and URLs in a configuration. And then, so this is a resource server. It's a REST controller. and it's serving a home page which is the same content as the previous one that I showed you, actually, the single page application. So I've now, the scenario is this: I've split my single page app into two. So I've got this backend service, which is working pretty much the same way as the SSO one does, except the filter it throws up, security filter it throws up is different. It's not looking for user authentication and redirects the login servers. It's just looking for access tokens. And so if it finds an access token, it's happy. If it doesn't, it sends a 401. That was actually the app that I was interacting with here. That one, resource.bfapps.io, needs a token and will send me a 401 if it doesn't get a valid one. That's what I just did again. And that's that app running there, this precise code. It's in that demo directory. I'll show you where that is at the end. What I've done is I've broken up that single page app. And on the front end, I'm going to put just a very thin static web service. And that little web service is going to want to that little web app is going to want to contact the backend services. And there are, as you probably know, restrictions on what JavaScript can do inside a browser. It can't contact another host, so you have to set special headers. And so we have done, in Spring Cloud, we have done this nice convention over configuration again, reverse proxy based on the Netflix tool container. So then what we're going to do with that is basically take the SSO client that we've got, the SSO web app that we've got, steal the token from that when it's authenticating. So to get the user authenticated, it has to grab a token. So we can sniff that, we can pull it out, and then we can put it into any request that goes to the backend server using this Zool proxy. So Zool is a bunch of rules and filters for sending requests to backend. It's not even HTTP specific, I don't think. Actually, probably is. But anyway, it's HTTP in this case. I'm just adding a token header to all the backend service calls. And what I'm calling that a relay of a user token. So the front-end app does a single sign-on with an authorization server. It doesn't collect the user credentials, but it allows the user credentials to be collected via the authorization server. It gets a token, and then that token just has to be saved somewhere so that it can be used in backend calls. It's a really simple pattern, so I think it's probably quite powerful just because of its simplicity. The possible flaw in this is that the front-end app has to acquire all the permissions it will possibly need to do everything in the back end. Otherwise, the services in the back end won't be able to serve the resources it needs because they won't have the right permission. So because it's a single token floating around all the way through the back-end flows, it's a little bit weak in that way, but it's such a simple pattern, and I think it might be popular. So we've implemented it as a simple auto configuration on that Zool proxy. So this is the token relay. So if I just take my existing OAuth2 SSO and just add @enable Zool proxy, that's all I need to do. And that will configure backend proxying for the backend services. So this requires service registry and all the other Spring Cloud things. But the cool thing is that it's relaying the token. So there's a Zool filter that gets installed that attaches the current user to downstream requests. The code is here. Oops, demo SSO.groovy. See, very simple. It doesn't have any controller endpoints because it's just a static web app with an HTML page. So the HTML is there, right? Don't need to read that and understand it, but it's going to render that ID. This is what I was showing earlier on with the single page app. So the difference with this is that it's going to proxy the backend requests. It's not going to serve them itself. And I guess I can show you that working. if I get rid of these cookies, there's that one definitely getting probably that one. Then if I go to, this is called SSO demo.vfapps.io. I'm going to log in as somebody else, different credentials on Cloud Foundry. Doesn't take me to the authorization page because I've already been there. But you can see that I'm getting my data from the back end. I could show you, using a neat Spring Boot feature, I could show you where that data is coming from. This is the trace endpoint from the Spring Boot actuator. So there are all the static resources being loaded. And here you've got a remote request. So the remote request is going to, it's from SSO demo to the service called resource. So that's a logical ID for the back-end service that's being contacted with this request, and the response is coming back with these headers. Oops. Okay, so moving swiftly on. We're running out of time. I could have spent a lot longer on this presentation. I could have given you more options. I gave you a few. The ones that I didn't, that I think would be relevant, would be OAuth1, which is sort of a precursor or predates OAuth2. It's got some nice features that OAuth2 doesn't, slightly harder to use for developers, but I think the main thing against it is just that it's sort of obsolete. I mean, there are still people using it, but I'm not sure I would use it in a new project. SAML is everywhere, so if you're in the enterprise, you're probably aware of it. There are ways to, the features of SAML end up being a lot like OAuth2. But you can use SAML assertions to obtain OAuth2 tokens, and then you're into some interesting scenarios. You can also, I think, consider physical network security as an important option for microservices if you literally just want to protect the backends from being accidentally accessed from public websites or public desktops. Then you can just lock down the network through IP tables everywhere. Kerberos is another common enterprise option, and there's some neat support for that in Spring. Officially, it's still at milestone release, but it's actually in use, and I know it's pretty solid, so it's definitely worth a look. And like I said, actually about SAML, there are combinations of the above, so you can use OAuth2 combined with any of these other things for authentication, for instance, like Kerberos to authenticate or SAML assertions to authenticate. That's quite useful, and something we've done quite a lot of work on actually at Pivotal with the UAA and Cloud Foundry. Okay, so in conclusion, we've seen how lightweight services are common and popular these days. We call them microservices. We want security in them to be solved, but we don't want it to be a problem. We want it to be unobtrusive, and so that's one of the goals of the technology that we've been working on here in Spring Security and Spring Cloud. Spring Security makes it easier for the Spring Cloud. Special mention for Spring Session. If you haven't looked at that, have a look at the project, have a look at the demo that I was mentioning, and also especially have a look at OAuth2. I think it has a lot of useful features for microservices, and Spring Security OAuth is there. Cloud Foundry has its UAA, which is implemented using Spring Security OAuth, so it's definitely worth a look at the code there. And that's the end. So I've got some links at the end that you can quickly copy off your screen if you want to know where to go to look up some of that stuff that I was referring to earlier on. You've got the Spring One demos there. You've got the Spring Cloud project that I was just demoing with those convention over configuration annotations there. We've got the basic Spring Security OAuth stuff here. Lots of sample apps. Best place to sample apps for Spring Security OAuth is in the integration tests, which are in the same project in GitHub. So I think maybe just a few minutes left if there are any questions. I'm sure there are, because I haven't been able to keep track of everything as I've been talking. I might have time for one or two.
We do, yeah. Actually, there are a couple. I don't think there's too many, especially if we can keep the answers brief. So let's see. A general question: is OAuth2 secure enough to use in enterprise environments like banks?
Well, I mean
it's subjective, right?
It's a subjective question. Yeah. I mean, yes. The answer has to be yes, right? I mean, I think that non-repudiation and not being able to tamper with requests is probably an important feature for some of those applications. But I mean, not every application inside a bank is the same anyway, right? And it's definitely, if you combine OAuth2 with request signing and SSL, then there's not much to say against it. And that's probably the punchline. So there's lots of debate around that. Lots of debate around that for sure.
Thank you. Parikshit asks, what are the different grants, and how do you determine which to use over another?
Yeah, again, that could be the subject of a whole presentation, which I have actually done in the past. Where did I have that? A little bit of a summary. So the grants are in the spec: authorization code, implicit, password, and client credentials. If it's unambiguous, if you don't have a user, then you use client credentials. If you do have a user, then the split tends to be between browsers and non-browsers. Okay, so non-browsers tend to use password grant. And anything that uses a browser, I would say can and should use authorization code grant, but you do have to think about it a little bit for a JavaScript client. So that's why they also provided the implicit grant as another option there. That's the sort of quick recipe decision tree.
Excellent. Thank you. I know we're trying to, summarize deep questions in like 2 minutes here. So let's see. Stephane asks, for me, you can't use the authorization code flow with a single-page app like a JavaScript app because the application or client secret can't be in the public domain. Do you feel that statement is right, wrong? What are your thoughts?
Definitely right. That's definitely right. So, I mean, it depends what your definition of a single-page app is, right? But yeah, you need redirect URI. So that's one of the strengths of it, right? That's the reason that I would recommend using the authorization code grant, because it has that extra level of security. You have to register a redirect URI, so you can't, you have to be trusted. You have to be a trusted client. So, I mean, it doesn't have to be a public URI, right? It just has to be one that the browser can reach. So, the definition of that depends on the environment you're in. In an enterprise setting, it could be definitely not an internet application, right? It could be inside the DMZ. So yeah, I mean, I do take the point, but I do think that it's worth having a think about. Technically, it's not really a single-page app anymore, right? Because you've got to have 2 pages at least. You've got to have the static content and the one that you use to receive the redirect and decode the token and everything, or acquire the token. So that you've got to have one tiny bit of active logic inside your app if you're using authorization code. But I think, I'm stretching some people's definition of a single-page app, but I don't think it's a really big stretch. It's maybe 2 pages, and it's not static, but it's a much better, secure solution. So I think that's what I would recommend.
Oh, Dave, now you did it. You started answering questions intelligently, and people are posting a lot more. You tell me where you want me to draw the line and cut it. I do want to remind everyone on the phone that there is, lucky for you, there is a 10 a.m. Pacific session. Poor Dave Syer, who's in England, is going to be staying up really late because he loves you guys. And if you want more, if you want to ask him more questions and we don't get to yours, join the 10 session, or maybe even post them in the comments of the blog entry when we post the replay. So you can save your question there, and then we can get to it out of band. So Dave, I'm gonna go for one more here. Is that too many? Is that all right?
That's fine by me. Yeah, I mean, I'm sure people have better things to do. But if there are still people on the line, then I'm happy to.
Well, we've still got 100 people on the phone.
Hello, everyone. What are you doing?
Ingo asks, can you also use the proxying without the cloud features using a custom self-hosted OAuth2 provider?
Well, the OAuth2 provider is independent of the proxy features I showed you. The proxying you could also use independently in Spring Cloud, but you need the proxy. You need to write that proxy logic, right? So installing it in your app and running it is a task that you'd set yourself in that case. I think Spring Cloud is probably going to expand to cover different use cases, right? So the one that I was showcasing there was where the back-end services are all in a service registry. So the obvious simple extension to that, or simplification of that, is where you don't need the service registry because you can hard code the URLs of the back-end. So if you're happy to do that, I think you could probably put that together quite quickly, and that might actually be a feature of Spring Cloud at some point in the future. The proxy code is a little bit tricky to write, and so I think Zool is a good container for that. I would recommend it, even if you were doing something simple like that. But I've written my own versions of that just using Spring REST template. It's possible to do that as well. So I think if I break that question down into two, OAuth2 is so those features are independent. Those the proxy features. The proxy features and the token relay are pretty orthogonal, and they're quite straightforward to implement, although you do need to be careful.
Dave, two questions that I think are kind of short, like maybe binary yes/no type questions.
Yeah.
If they're long and you want to punt, let me know. Would tokenization still work with a cookie disabled?
Yeah. Well, it depends. So, my recommendation to use auth code grants in a single-page app kind of requires cookies, but implicit grant doesn't. So maybe that's the answer. Password grant definitely doesn't require cookies, right? Because it's mobile. Similarly, client credentials. So the only one you would ever see cookies involved would be the authorization code, and it's the most secure, it's the most convenient for a browser app. So I would still recommend using it, but it does require a session on the server.
This is going to be okay. Cool. Oh, sorry.
No, go ahead.
Sorry.
It's fine.
I think this one's also simple. For basic auth with Spring Boot, can I disable security for certain endpoints?
Yeah, it's in the docs. You just do security.ignored equals and then a comma separated list of paths.
All right, last question, and this is my personal favorite of the list, so the award goes to Zoltan. What is the roadmap for Spring Cloud?
Roadmap. Well, Spring Cloud Security is in the in the 1.0 roadmap. So everything I showed you there is the timelines. You can look in GitHub. There are milestones defined in. So if you go to github.com/springcloud and look in the repositories there, the ones that are going to be released have got timelines defined in GitHub milestones. Basically,
I think maybe he's going in the vision. I think maybe he's going in the vision direction.
Timeline. Okay. Well, the vision is we start with 1.0 as soon as possible, which means sometime this year, early next year. So Q1 2015. And by simple as possible, I mean we do a lot of wrapping of Netflix OSS, so using Zool in the demos that I gave there, wrapping existing technologies like Spring Security OAuth2, Spring Boot, and leverage them as much as possible. So that's the 1.0 vision, basically. There's a Netflix thing, there's a config server, there's security, and that's probably it for 1.0. Looking further down the line, we want to cover different options for all the features that we've already done in 1.0, basically. So if you want to do service discovery, it doesn't have to be Netflix service discovery, for instance. That will be one part of the roadmap. There are new features that we'd like to do as well, like leadership election, cluster state, that kind of thing. What else? Maybe different options for configuration management as well. Maybe some sort of dashboard thing, so you can sort of get a UI view of everything. There's a lot of work we can do with metrics, especially with Cloud Foundry. So also on the Cloud Foundry front, if anybody's looking at PCF, which is the Pivotal Cloud Foundry sort of in-house enterprise product, we're looking to make it sort of a turnkey solution so that you can build microservice systems really quickly. And all the features of Spring Cloud will be sort of part of the platform, binding to services, basically. So that'll be a chunk of work that we'll start on pretty soon as well.
Yeah, Cloud Foundry ships. Cloud Foundry ships UAAs. Don't they provide an OAuth2 kind of server implementation?
Yeah, I think the latest version of PCF already has the UAA as a service. And,
right.
They're working on something different at the minute, which is kind of a tenanted identity management thing. There's also the mobile as a backend features with PCF, which are actually using Spring Cloud in a couple of cases. So we're collaborating with those guys on that. The Spring Cloud team and the mobile team are getting together to make sure that we share best practices and use Spring Cloud wherever we can. I think that's broadly speaking, that's the roadmap. I mean, more features and different options for implementing the existing features is sort of the high-level summary.
Dave, thank you very much. Appreciate you going, 10 minutes over to capture some questions. I think we only missed, I think I left 2 off the table. So folks, feel free to join the next one or post your questions as comments to the blog when we do post the replay. Speaking of which, we do record these webinars. We will be posting a replay. It will be available within the next 2 weeks. So if you'd like to get a notification about when that webinar is available, please do subscribe to our Atom feed at spring.io/blog. Or if you just want to do the YouTube video for some reason, you can subscribe at spring.io/video. We will post a link to the slides. Dave we always upload our slides to Speaker Deck, and then we'll put a link to the Speaker Deck in the YouTube recording and on the blog. Within a week or two, this will be available to share with your colleagues, and I suspect that this will be widely shared and linked to as microservices is so popular lately, and security is definitely a huge part of that. And so, Dave, thank you very much for joining us for what's clearly an important topic, a timely topic, and not an easy one. So, deeply appreciate your insights here. Thank you, Dave.
Thanks.
Yeah. Anything you want to say before we call it a wrap, Dave?
No, I'm fine. Some interesting questions.
Great.
I wish I had more time to go into the questions, but I'm quite happy to answer that. That's for people who are interested.
All right. Well, geez, we still have 62 folks on the line. Hey, thanks, everyone. Really appreciate it. Like I said, if we missed your question, please post it as a comment on the blog once we release the replay, and we'll get you taken care of. All right, folks. Have a great day, or come back and join the 10 a.m. session. You could always do that. Thanks a lot, folks, and talk to you later. See you on a webinar soon. Bye-bye.